Have you ever wondered, where did everything come from? How did our universe begin? It's a profound question, one that has puzzled philosophers, scientists, and curious minds throughout history. Our cosmos, with its myriad galaxies, stars, and planets, didn't just appear out of nowhere. The most widely accepted explanation among scientists is the Big Bang theory. It suggests our universe sprang from a point of incredibly intense heat and density, expanding rapidly and cooling over time. This explosive event not only created matter and energy, but also space and time themselves, around 13.8 billion years ago. Yet despite its wide acceptance, the Big Bang theory leaves some questions unanswered. What sparked that initial singularity? What was there before it? What exists beyond what we can observe? These are the cosmic mysteries that continue to keep cosmologists up at night. Let's take a journey back in time to the very beginning, to the Big Bang. The Big Bang theory. You've heard about it, but what exactly is it? Well, let's dive in and simplify this cosmic concept. The Big Bang theory, in essence, is the most widely accepted explanation about our universe's birth. It's not about a colossal explosion that randomly happened in space, as the name might suggest. Instead, it presents the idea that the universe itself began from an incredibly hot, unbelievably dense point of energy and matter. Imagine all the energy, all the galaxies, stars, planets, everything that exists, compressed into a tiny, almost infinitesimal point. Then, in a fraction of a second, this point started expanding rapidly. As it expanded, it cooled down and the energy transformed into particles, which eventually formed atoms, stars, galaxies, and everything we see around us today. This event, this incredible expansion, is what we call the Big Bang, and it marked not just the birth of our universe, but the start of space and time as we know them. The universe, according to this theory, is about 13.8 billion years old. Quite a lot of candles on the cosmic birthday cake, wouldn't you say? But don't imagine the Big Bang as an event that happened at some particular spot in the universe. Instead, it happened everywhere at once. The universe didn't expand into space. Space itself expanded, carrying galaxies along with it. And it's still expanding even now as you're listening to this. Yet for all its explanatory power, the Big Bang theory leaves us with many unanswered questions. What caused the initial singularity? What existed before it? What lies beyond the observable universe? These are some of the mysteries that continue to baffle and tantalize cosmologists today. But how do we know this? What evidence supports this theory? Stay tuned as we delve deeper into the cosmic clues that lend credence to this awe-inspiring theory. Opening. The Big Bang theory isn't just a guess. It's supported by a body of evidence from cosmic microwave background radiation to the redshift of distant galaxies. The Big Bang theory, the prevailing cosmological model for our universe's observable life from the earliest known periods through its subsequent large-scale evolution, is not a mere speculation. It's a theory rooted in a multitude of scientific observations and calculations. Two of the most compelling pieces of evidence are the cosmic microwave background radiation and the redshift of distant galaxies. Imagine the universe as a stage, and cosmic microwave background radiation as the faint echo of the opening act. This radiation is the afterglow of the Big Bang, a whisper of light that has been traveling through space for nearly 14 billion years. It was first discovered in the mid-20th century and gave scientists a snapshot of the universe when it was just a few 100,000 years old. The uniformity of this radiation across the cosmos aligns perfectly with the Big Bang theory's prediction of a universe that started from an incredibly hot and dense point. Now let's turn our cosmic gaze towards the redshift of distant galaxies. When we observe galaxies far, far away, we notice something peculiar. Their light appears redder than it should be. This is known as redshift. It's akin to the Doppler effect you experience when an ambulance passes by, its siren changing in pitch. In the case of galaxies, as they move away from us, their light shifts to the red end of the spectrum. This observation indicates an expanding universe, again a direct prediction of the Big Bang theory. These pieces of evidence, among others, provide compelling support for the Big Bang theory. However, as with any scientific theory, it's not without its flaws. Despite the observations and calculations, the Big Bang theory does not explain what caused the initial singularity or what existed before it. It also leaves us pondering about what lies beyond the observable universe. Closing. But the Big Bang theory isn't perfect. It leaves some big questions unanswered. What caused the initial singularity? What existed before it? What lies beyond the observable universe? The Big Bang theory doesn't have all the answers. As we delve deeper into the mysteries of the Big Bang, we encounter questions that remain unanswered. The Big Bang theory, while widely accepted, is not all-encompassing. It gives us a plausible explanation of how our universe came into being, but it doesn't tell us why or what triggered this event. This initial singularity, a point of infinite density and heat, is still a puzzling concept. What caused this concentration of energy and matter to suddenly explode and expand? As of now, the catalyst of the Big Bang remains one of the greatest mysteries in cosmology. Then comes the question, what was there before the Big Bang? This question takes us into the realm of speculation and theories, as the laws of physics as we know them break down at the singularity. Some cosmologists propose the idea of a cyclic universe, where Big Bangs are just one phase in an eternal cycle of expansion and contraction. Others suggest that our universe might be just one among a multitude in a multiverse, each with their own Big Bangs. Finally, we ponder on what lies beyond the observable universe. Our vision of the cosmos is limited by the speed of light and the age of the universe. We can only see as far as light has traveled since the Big Bang. But what lies beyond that cosmic horizon? Is the universe finite or infinite? Are there other universes out there beyond our grasp? These unanswered questions don't undermine the Big Bang theory, but rather highlight the vastness of the unknown. They push the boundaries of our understanding and ignite our curiosity. In the end, these mysteries fuel our pursuit of knowledge, drive our scientific advancements, and inspire us to keep exploring the cosmos. These mysteries are what make the study of our universe so fascinating. The unanswered questions of the Big Bang theory aren't stopping scientists. They're driving them to explore further. As we delve into the future of cosmology, we find that researchers are not daunted by these mysteries. Instead, they are motivated by them. The enigma of what caused the initial singularity, what existed before it, and what lies beyond the observable universe are the very fuel that propels them forward. In this quest for knowledge, scientists are developing new hypotheses and conducting innovative experiments. They're pushing the boundaries of technology to observe the universe in ways that were unimaginable just a few decades ago. From using powerful telescopes to peer into the furthest reaches of the universe, to creating complex computer simulations to understand the behavior of galaxies, every day brings us closer to unraveling the secrets of the cosmos. Some cosmologists are exploring the concept of multiverses, a theory suggesting that our universe is just one of countless others. Others are delving into quantum mechanics to explain the initial singularity. There's even the fascinating field of dark matter and dark energy, invisible elements believed to make up more than 3/4 of the universe, whose nature remains largely unknown. These hypotheses may seem like something out of a science fiction novel, but they are grounded in rigorous scientific research. Each one offers a potential piece of the puzzle that is our universe, and each experiment brings us a step closer to the answers we seek. The future of cosmology is bright, filled with promise and potential. With every new discovery, we get a glimpse into the origins of our universe, and perhaps even into the nature of existence itself. As we continue to explore, we are reminded that the universe is not just a vast expanse of space and time, but a grand mystery waiting to be discovered. So, next time you look up at the night sky, remember, you're not just looking at stars. You're looking at the mysteries of the universe waiting to be unraveled. Be